This here is a new mini PC from GMK. I've reviewed many GMK products and I like them. I use one of their eGPUs as a daily driver myself. This here is the K13. This is a brand new one from them. This here uses a Lunar Lake CPU. So Lunar Lake offers some really nice benefits in being lower wattage, offering reasonable performance despite those very low wattages, having a very good iGPU on it, also being good for more simplistic but local AI, because it does have good NPU. So if you're doing, I'm not talking like giant AI models, but I'm talking about, you know, doing localized AI type stuff that would be more for productivity. It's got you covered. It's a nice dense little package here, very small. It always look bigger on camera, but it's a very small little thing. Like here's my phone, right? Like it's not that much, maybe 1.5 centimeters bigger than my phone that way. Obviously it's thicker that way, but it's a nice little machine there. You can see very clean little package. Exhaust out there. Well, that might be the intake. That's probably the exhaust out there. All right, nice little dense package. Very nice. Nice and unassuming if you set it up, right? If you put it up here or something like that. A nice little package you wouldn't see. Put that up a little bit there. Very nice. I might actually set it there for part of the review. Usually when I'm doing a review, I actually pull it out just so it's in the camera, but that would be actually kind of cool. Set it right there. Anyways, so on the front here, we have two USB-A, faster USB-A, microphone headphone combo jack, nice clean, going with the green GMK design. And then on the back there, USB 4, obviously very nice to see that. USB 4 is going to facilitate a lot of things. You'll be able to run, you know, NVMe enclosures like this here. You'll be able to run docks, hubs, expand your storage, expand your ports, because, you know, this thing isn't like a desktop. It doesn't have that level of ports. It's actually decent, but you're gonna be able to really expand it with that. You could run an eGPU off of this and also run a dock at the same time, so that's nice. HDMI out, obviously. USB-A, the slower one. So this for me is going to be where I put in my USB dongle for mouse and keyboard. Of course, you can use Bluetooth as well. Kensington lock slot, reset, and then your Ethernet. So to get inside this is actually, honestly, it's the easiest mini PC I've ever got into. You take out one screw and then this just pops right off. Right, plastic bottom there, some magnets on it to keep it so it's nice and easy to pop off. And then anything you really want to access until maybe years down the road servicing is right here. This is what I like to see. We have our NVMe 1, the one that's actually in the actual machine, which is a Huawei. This is the second one I've seen in my life. I've never, this like a week or maybe like a month ago, I think was the first time I'd ever seen a Huawei SSD, and now it's the second time, so that's cool. Second slot right there, so easy to upgrade right there. Wi-Fi is right here as well, and your CMOS battery. So everything you really want to service is right here. Your storage, your Wi-Fi, and your CMOS. Again, years down the road, sure, maybe you want to service the paste or something. You know, you can take it apart a little further, pop these off, pull the shell off, get a little deeper. But as it is right now, everything that you really want to get into is right here. And it's a nice dense little machine, so everything's nice and compact in here. Very, very nice. Okay, here we are set up. Been using it for a little bit, just kind of testing it out. Nice clean little package. I did decide to just sit it there. It's nice and cute. Fits perfectly into this monitor. I'd actually normally leave my monitor right around there. So it actually fits literally perfectly under that. So nice clean little unassuming box. Looks great. Check the idle noise. There really isn't. When it's not doing anything, there is no real noise, obviously. Right, it quite literally is silent. Now, one thing with Lunar Lake is not some like monster CPU. So when you do complicated tasks, it has to work a little bit harder than, say, a more powerful CPU. Meaning, you know, it's going to be working a little bit harder, potentially put a little bit more watts into it. But when it's not doing anything, it's incredible. You can see down here, it might be hard to see on camera. I'll bring you guys in a little bit here, but look at the idle watts here. Isn't that insane? Like 1 to 2 watts. So we get the 256V. That model, like I said in the teardown, does come with the RAM on it, on the chip itself. So it comes with that chip. It comes with the RAM on the chip, so you can't get more. But it does have 16 gigabytes, and it's very, very fast. Yeah, it's not like a big monster, you know, 64 gigabyte module or something like that, but I suspect for a lot of work you would be targeting something like this, it's going to be totally sufficient, right? Very good. And again, like I said, it's very fast, and that will be important when you're doing GPU level tasks. The NVMe we already said was that Huawei one. Realtek Wi-Fi 6E, no problems there. And the other thing is we do get that 140V. So you can do a lot with that iGPU. Anyways, so we'll come in here, we'll look at a few benchmarks here before we jump in, and I'll show you the noise and the thermals and that. Just some very simple stuff here. Obviously that Huawei NVMe is very fast. Gen 4 speeds, upper Gen 4 speeds, so that's good. The Wi-Fi is good. I don't have good Wi-Fi, like I don't have good internet, but my Wi-Fi, that's about as fast as I can possibly get. Tiny little box, no real antenna sticking out of it. That's good Wi-Fi speed for me. Uploads don't matter, but that's as good as I can get. Even with a nice, like a tower with big Wi-Fi antennas, that's about the same. So that's good. We'll run some Cinebench here. Again, it's not a Cinebench monster. It's a 8 cores, and there's no like hyper-threading here. So it's just an 8-core CPU with very low wattage, very efficient. It's meant to be efficient, is what it is. But it's still capable. Like you can still do a lot. You can see here, you know, I did a run through, gave us around 8,000. It's totally fine, right? It's going to be efficient type CPU, much faster than something like, you know, you get those Intel N150s, you know, those Intel N150s you can get in like some of these small machines. It's not even close to as fast as this. This is twice as fast or something like that. So yeah, this is very capable, right? Those N150s sit around here. It's like I said, it's completely silent when you're not doing anything, which makes sense because it's not using any watts. This is not a super high wattage machine, you'll see here. So very, very, very low watts. See that? They're 20 watts under full load. And that's the thing here. If you don't want, like if you're in a hot environment, you don't want, right, like a really, really annoying fans, you don't want lots of heat being produced, you're going to struggle to find a machine that's going to be lower watts than this and still capable. Now the fans are just starting to kick in, but they're still very quiet. Like 1 dB above my noise floor. It's so quiet. I mean, again, it's 20 watts. It's not hard to cool 20 watts, to be honest. Now, again, it's not the biggest monster, like a 275HX or something like that, but it's not supposed to be. And it's going to be, like I said, much more capable than something like an N150. I actually find with those type systems, you know, those little Intel N150 type systems, if you're just doing day-to-day, very basic stuff, it's totally fine. This is a level above that, where you're still getting that very high level of efficiency, but this is like a truly capable chip now all of a sudden, right? So we can come in here, we'll take this video in here. This is the video editing software that I use here. So bring that in. This is a big video too. This is a 4K 60 video, and it's 27 minutes. Get that out of there. And you know, we're immediately able to, like, we're playing the video, right? It takes probably a minute to fully process the video completely to the point where we can just rip through it. But even now, like, see? And you can see now we're hitting the system a little bit harder. It's processing that video. It's going to be a little bit more demanding, but it's still very capable. So the nice thing is here, like, we can come in here, and this is snappy, right? The 4K 60 videos, it's nice and snappy. Like, there's no lag here. It doesn't feel like I'm fighting against the system at all. This feels fantastic. And this has capable NPU. So NPU is neural processing unit. I'm not the biggest AI guy. If you know me, I'm not into AI at all. But when I say that, I'm not into off-site AI, like big data centers. I do not like that. Local AI is a totally different thing, because this is NPU, this neural processing unit, is going to be used to do localized AI. So if you are doing things like, yeah, I know Copilot is bad and all that kind of stuff, but Copilot can actually be pretty useful. To be honest, if you use Copilot, Windows, like even like Paint, Microsoft Paint has AI stuff in it now where you can actually, like, there you go. You can generate stuff. You can actually come in here and you can start to, like, I've done this before. I think it's Image Creator. You can come in here and you can type some crap. You have to log in, but like log into your Microsoft account. But you can come in here and you can type in, like, yeah, forest, and you can do that. You can also come in, you can actually start, like, draw stuff, and it will turn it into AI as you're going. It's pretty sweet, to be honest. So that's done locally, right? Right, it's generated a little thing right there. Right, and this is done locally. Like, it's not done over the cloud. You don't even need to be connected to the internet. It'd be user credits or whatever, and you come in here and it'll just generate it for you. So pretty sweet. And then you can do, like, you know, effects and that kind of stuff, and that'll use the NPU. The editing process, like this part here, uses the CPU, so this is all very good. And then the last thing here is when you're actually exporting, rendering the video itself, then you're using the little bit of CPU, and you're also using primarily the iGPU. Like that there, use the NVIDIA NVEC. And again, this is going to hit up it'll hit the CPU as well, but most of the rendering here is done on the GPU, right, the iGPU. And having this 140V is actually a very capable iGPU here. Come in here, we'll just export that, doesn't really matter. All right, we'll slam that GPU there. It'll hit the CPU as well, of course, but you can see 100% on the GPU there, and CPU is kind of auxiliary there, and it'll render this video pretty quick, to be honest. Intel is very good for this. We'll see how long it goes, but 5-minute video, I don't know how long this is going to take, maybe 4 minutes or something like that. It'll rip through. That's pretty typical for like an upper end iGPU. And again, the 140V is an upper end iGPU. It'll be very good. 1/3 of the way down in 33, so it might be quicker than I thought. Actually, it might be like 3 minutes. Cancel that out. Anyway, so if you're doing things like this, video editing, these professional tasks, you may look at this and say, can you do this type of work on a system like this? And of course you can. Yeah, it's much more capable than you might think, right? This is, maybe not the CPU if you're doing like heavy code compile or something like that, right? Or game editing. Like if you're creating games, maybe not the way to go. You want more cores, you want more RAM, all that kind of stuff. But when it comes to this type workflow, this is very good. This is not a CPU that's just specifically for like only word processing, like an N150. It's like, yeah, you can watch some YouTube and do some word processing. No, this is like I'm doing heavy video editing here. There we go. Anyway, so it's going to be quite good, right? So we can see here, let's just stop for a second so I can talk. It's running really well. So you can see here, yeah, we're in Spider-Man, and we're at 1080p with some scaling in that. And, we're not cranked up or anything, but I mean, 45 FPS, right, with some XeSS. XeSS is very capable, very good. It's better than FSR if you know anything about scaling. I don't want to get too much into the technicalities here, but if you know about scaling, you know that FSR is here, XeSS is here, and a DLSS is probably the best right now. FSR 3, 3.1, whatever, is going to be well behind what XeSS can do. So Intel has specific type of upscaling where not only does it look better than FSR, because it works on anything, but FSR actually gives you performance boosts when you have native Intel hardware, right? And you're going to get really good performance, right? You're going to be able to play a lot of these games. Honestly, any AAA modern game should run just fine. Older games are going to fly and just scream on this thing. But, it's like 1440p, even 4K, depending on the game, to be quite honest. But, there's going to be games like this, AAA modern games, that you're going to want to play with the settings a little bit, but you'll get good gameplay, right? You'll get good gameplay. The biggest issue with this specific system is you only have 16 gigabytes of RAM, so Windows will eat up a fair bit of that with the games and that too, and then the rest going to the VRAM. But you can see there, even with this game running, Windows running, and the game, we're still not even using all of the memory available to us. So, we're doing pretty good here. Okay, so now we can see here, all of a sudden I'm at 1440p. Now, not only do we have higher frame rates than before, not massively higher, but we're getting pretty good frame rates here. And I've just kind of thrown this up here, but we can see, what we were getting before, I don't remember, something around here, 45 to 50 or whatever. But now I'm at 1440p and I'm almost on high. So I went from low 1080p to 1440p and high. And I turned down scaling. So what did I do? Well, let me show you. Turn on that light there, come down here. And this is my little baby right here. This is also GMK. You can see this is the GMKtec. This is the GMKtec. This is the GP1. It has a 7600 MXT inside of it. It's a Thunderbolt 4 USB 4 capable. It also has Oculink, but USB 4 capable. And all I did is I just ran this cable right here. I've just kept that up so you can see it. Ran it in the back. And all of a sudden, I'm using that as an eGPU. There are other eGPUs you could use as well. If you wanted to use something even bigger, right? You could put on a 5070 Ti desktop or something with that. But this is a good pairing, right? This is a good level for something like this. You get the Lunar Lake CPU here. It's not going to have too much of an issue supplying a GPU of this caliber whatsoever. And you can see, I mean, I could turn this down. I could put the settings more. I just basically came in, put it to 1440p instead of 1080p, turn the settings up a bit, and turn down the scaling, and all of a sudden we're getting similar type frames, but way, way, way more demanding. And it's made capable by that Thunderbolt 4 port in the back, the USB 4 port, sorry. And because it has two of them, I can run a dock like this, eGPU style device here. And then I can also run something like, a USB 4 enclosure like this, one that actually has like ports on it and all kinds of extra goodies as well, NVMe inside as well, so you can really expand it. So this is a little mini PC that's very capable as it is, very useful as it is, doesn't cost a lot, but you can actually expand it quite a bit because it has two NVMe's inside, very easy to expand there, and you also get access to Thunderbolt 4 and two of them, or USB 4 and two of them, so that's very nice.